All right, Miss Teasley here. I am going to continue our lessons on equations. Last time we talked about quadratic equations, solving quadratic equations. This lesson is going to talk about all of the other types of equations that we're going to cover in this unit. All right, so we're going to start off with example 1. All right, example 1, this is a polynomial equation, x to the third minus 16x equals 0. Our goal is to solve for x. Notice how the highest exponent is 3. So that means that you should have 3 solutions. Sometimes the numbers repeat, but overall you should have 3 different solutions for this equation. All right. So the way that we do this is you want to make sure that everything is set equal to 0 like it is, and you want to factor. All right. Well, the first thing I do with factoring problems like this is I factor out a greatest common factor. The greatest common factor in this equation will be x, and that leaves me with x squared minus 16 equals 0. And then what's in parentheses can be factored more. This is a difference of squares. When you factor that, that's x minus 4 times x plus 4. So again, factoring is a very important concept that you need to know how to do in order to be successful in this unit. All right, so what I'm going to do now to get all 3 solutions, I'm going to set all 3 factors equal to 0. X equals 0, x minus 4 equals 0, and x plus 4 equals 0. And then you solve all 3. Well, the first one is already solved, so that's my first answer. Here, to get x by itself, I need to add 4 to both sides. So x equals positive 4. And here I'm going to subtract 4 from both sides. And I get x equals negative 4. So those are all 3 solutions to this equation. And in my math lab, you would just type it in a box separated by commas, 0, 4, negative 4. All right. I'm trying to, all right, 0. All right. So now moving on to the next example, this is another polynomial equation. In order for you to solve this problem, everything will need to be set equal to 0. So before I even get started, I want to put everything on one side of the equation. Your highest exponent is x to the third, so you want to bring everything over to that side. So what I'm going to do is I'm going to subtract 12x squared from both sides. And you put it in order. You have 8x to the third. You have a 6x, and you have this minus 12x squared. The minus 12x squared should come behind the 8x to the third. All right, you put them in descending order. You still have that plus 6x. And on this side, you only have a 9 left over. Again, you want everything set equal to 0. So now I'm going to subtract 9 from both sides. So you just stick that 9 right behind it. And then I'm going to have to factor and solve. So I encourage you to pause the video and to factor and solve this equation like we did before. And then come back and, check your solutions from after working it out on your own. All right, so moving forward, I'm going to go ahead and factor. So problems like this, you want to factor out. This is factoring by grouping. So you want to group them in pairs. Remember, the highest exponent is 3, so you're looking for 3 solutions. So factoring by grouping, you have to factor out the greatest common factor in both parentheses. In this first parentheses, the greatest common factor will be a 4 and an x squared. And when I divide both of these by 4x squared, I'm left with a 2x minus 3. Over here, my greatest common factor will be a 3. All right, so positive 3 plus for positive 3. And when I divide both of these by 3, I'm left with 2x minus 3. So the greatest common factors go in a parentheses by itself. So 4x squared plus 3 go together. And then you put the 2x minus 3 in a parentheses. All right, so this is the complete factor answer. And then you have to solve. So to solve, you have to set both parentheses equal to 0. So coming over here, 4x squared plus 3 equals 0. And then 2x minus 3 equals 0. delete this. So equals 3. So I'm up here now at the top. Notice in the first equation there's an x squared. This is a quadratic. That means I'm going to have 2 solutions from this one equation. So this is going to take us back to the last lesson. So I need to subtract 3 from both sides. I get 4x squared equals negative 3. Your goal is to get that x squared by itself first. So you divide both sides by 4. And then I get x squared equals negative 3 over 4. To get the x by itself, you need to take the square root of both sides. So I'm taking the square root over here. When it comes to fractions, you have to take the square root of the top number and the bottom number. And remember, whenever you introduce a square root into the problem, you need to put a plus or minus symbol. So what we have is x equals plus or minus. At the top, I'm taking the square root of a negative 3. So since there's a negative, that means an I is going to come out. So this becomes square root of 3, and the I is going to be on the outside. All right, this is equivalent to the square root of negative 1 times the square root of 3. All right. So moving forward, you could just, anytime you see a negative underneath the square root, just go ahead and pull out your I. The square root of 4 is 2. So here are your 2 solutions from this one equation. Positive and negative, square root of 3 over 2i. You can leave the I at the top with the 3, or you could put it right beside the fraction. All right, so either or will work. Let me see if I can move it. If I can move it here. So you could put it beside the fraction also. And then the last part of this equation, I need to solve this 2x minus 3. So I'm going to add 3 to both sides. That's 2x equals 3. Then I'm going to divide both sides by 2. So x equals, let me go ahead and delete this. We don't need this anymore. X equals 3 over 2. All right, so those are polynomial equations. Now we're going to move on to radical equations. So radicals, if you notice the next example, hold on. I'm gonna have to close this out. All right, my screen froze. Alrighty, I don't know if I opened up the right file. Let me see. Nope, that's not it. All right, give me a moment. Sorry about that. I don't know, my iPad just froze. I'm trying to make sure I have the correct file. I think I'm here. All right, here we go. All right. So now my goal is to solve this radical equation. All right, so your goal is to get x by itself. All right, so if you notice, in order for you to get x by itself, you have an x over here beside this plus 1, and you have an x underneath the square root. So first thing you want to do is you want to get rid of the square root. All right, so in order for you to get rid of the square root, you want to square both sides. So the issue is trying to get rid of this square root. So I'm going to put a parentheses on both sides, and I'm squaring both sides. On the right side, if you're squaring a binomial, you have to square it together. This is the same thing as x plus 1 times x plus 1. You could just write it twice. On the right side, the square and the square root cancels out, so I have x plus 13. On this left side, I'm going to have to multiply this out, so you'll use FOIL. So x times x is x squared. X times 1 is 1x. Then you come back, 1 times x is 1x, or just x. And then 1 times 1 is positive 1. So I use FOIL, first, outer, inner, last. Combining like terms, you get x squared plus 2x plus 1 equals x plus 13. So now your goal is to get x by itself. All right, but in order for you to do that, I see this x squared pop up. So that means I'm dealing with a quadratic equation. And in order for you to solve a quadratic equation, you want everything to be set equal to 0. So I'm going to subtract x from both sides. That leaves me with x squared plus 1x in the middle plus 1 equals 13. You also want to get rid of this 13 over here because you want it to be 0. So I'm going to subtract 13 from both sides. So I get x squared plus 1x minus 12 equals 0. And then you want to factor and solve. Right, so hopefully this factors nicely for us. When I factor this, I get x and x. The two numbers that multiply and give me a negative 12, but add and give me a positive 1 will be a plus 4 and a minus 3. And then to finish this off, I will set both parentheses equal to 0. So I will subtract 4 from both sides. X equals negative 4. And then add 3 to both sides. X equals 3. All right, the only thing about these problems is that before you put these in as your final answer into My Math Lab, we have to check both solutions to make sure they work. So you have to check for what we call extraneous solutions or extra solutions that popped up. And if you put any solutions in My Math Lab that doesn't work, it's going to mark it wrong. All right, so let me show you how you would go about checking it. You would go over here. So we're checking our answers. And that's for any of these radical problems. You have to check your final solutions. So I'm going to write down the original equation. And I'm going to check both answers. I'm going to check negative 4 first. So in place of x, I'm going to put negative 4 plus 1 equals the square root of negative 4 plus 13. So I get negative 3 equals the square root of negative 4 plus 13 is 9. The square root of 9 is 3. You don't put a plus or minus symbol in front of it because there's already a square root here. So you ask yourself, well, does negative 3 equal negative 3? And the answer is no. So since that's the case, you have to toss out negative 4 as a solution. So over here, negative 4 is extraneous. So you wouldn't put it, or extra for short, you wouldn't put that into My Math Lab as a solution. Then I have to check x equals 3. So now I'm going to check x equals 3. So go back to the original problem again. X plus 1 equals the square root of x plus 13. So this is 3 plus 1 equals the square root of 3 plus 13. And I'm just trying to see if both sides are equal. So 3 plus 1 is 4. Over here I get the square root of 16. And the square root of 16 is 4. So it checks. So that means that the only answer, this is your only solution. All right, the other one is called extraneous, or extra for short. All right. So moving forward. All right. We're not going to do this problem. You won't have anything like this. All right, we're going to jump and do example 5. All right, so if you notice here in example 5, you have a radical equation, but in this example, you have two radicals. So when you have problems that has two radicals, first thing you want to do is you want to isolate one of them, which in this case, I have this square root of 2x plus 2 over here isolated by itself. So what I'm going to do is, since that square root of 2x plus 2 is there, I'm going to square it so I can get rid of the square root. So my purpose right now is to get rid of the square root on the right side. Over here, this is the square root of x minus 1 times the square root of x minus 1. All right, on the right side, the square and the square root cancels out, so that's my 2x plus 2. Over here, you can use FOIL on the left side. I'm going to use the box method. You can always use box method. I like box method because everything is nicely organized and you can work within the boxes. So the square root of x and a negative 1, square root of x, negative 1. So the first time I'm going to multiply everything at the top by the square root of x. All right, so everything here at the top I'm multiplying by the square root of x. The square root of x times the square root of x is just x, all right, because they cancel each other out. Then here, the square root of x times -1 is negative square root of x. You just put that -1 in front of the square root. Then I come down here and multiply everything at the top by -1. So -1 times the square root of x is negative square root x. -1 times -1 is +1. And then you add like terms. All right, this is terms. Uh-oh. So I have an x here, a +1, and then the only two that you can add together will be these negative square root of x. You have two of those, so it becomes -2 square root of x. So this right side over here, when you multiply, this is what you get. X plus 1 minus 2 square root of x. And then you have this 2x plus 2 on the right side. All right, again, now you see another square root of x. All right, so you have another square root over here that you need to get rid of. So in order for you to do that, you want to isolate it, get that green stuff by itself. So to do that, I'm going to subtract 1 from both sides. So this is x. This minus 2 square root of x is behind it. 2x. And 2 minus 1 is +1. Then I'm going to subtract x from both sides, because my goal is to get this square root stuff by itself. All right, so when I do that, I get -2 square root of x equals 2x minus x is 1x plus 1. And now at this point, we want to go ahead and square both sides. Even with the stuff in front of you, you want to square it. When you square something like this, you have to square the -2 first, and you have to square the square root of x. So you square both factors. Over here, we're going to write this twice. When you square a -2, you get 4. When you square a square root of x, you get x. And over here, I'm going to have to use FOIL. X times x is x squared. X times 1 is +1x. Then you come back and multiply everything by 1. So this is 1x, and 1 times 1 is 1. Combining like terms, I get x squared plus 2x plus 1. All right, you still have that 4x over here. And then your goal is to get x by itself. So we're going to subtract 4x from both sides. So here's my 0. All right, you want everything on one side of the equation. It's a quadratic. So x squared minus 2x plus 1. When you factor this, so now we have to factor. The 2, I get x and x, and two numbers that multiply give me +1, but add and give me -2 will be -1 and -1. At this point, you set both factors equal to 0, which they end up being the same. So you add 1 to both sides, x equals 1. Same thing here, x equals 1. So you only have one solution, which is x equals 1, but you need to check it to make sure that this solution is acceptable. All right, so make sure it's not extraneous. So I have to go all the way back to the top and check x equals 1. All right, so over here, I'm going to check x equals 1. Sorry about that. We go to the original problem, which is the square root of x minus 1 equals the square root of 2x plus 2. So any of these radical problems, you have to check your solution. Everywhere I see an x, I'm going to plug in a 1. So this is the square root of 1 minus 1 should equal the square root of 2 times 1 plus 2. So in place of x, I put a 1. The square root of 1 is 1, so this is 1 minus 1. Over here, this becomes 2 plus 2. 1 minus 1 is 0. This becomes the square root of 4. I get 0 equals the square root of 4 is 2. This is definitely not true. So that means x equals 1 does not work. These are extraneous. All right, this is the correct word. Extraneous. I say extra for short. So since you don't have any solutions, any other solutions to choose from, your solution is no solution. So there's no solution. We did all that work. There's no solution. The symbol in my math lab for no solution is a circle with a line through it. All right, so that would be your answer. You would just click the box that has the no solution symbol in it. All right, so that one was probably the most challenging problem in this section. So definitely have to practice those. All right, it requires a lot knowing how to factor, knowing how to solve equations. All right, so here is another radical equation, except they have it written in rational exponent form, and we talked about that before. All right, give me 1 second, let me see. All right. So for problems like this, you want to leave it as a rational exponent. And your goal is to get rid of the rational exponent. So to get rid of this 2 over 3, I'm going to raise both sides to the reciprocal, which is 3 over 2. The reason why I'm using a reciprocal is just a fancy way of saying flip the fraction, is because when you raise a power to a power, you multiply. When you multiply reciprocals together, they become 1. So 3 over 2 times 2 over 3 just becomes 1. So this becomes x minus 1 to the first power. All right, and this becomes 4 to the 3/2 power. All right, so I did that because I wanted to get rid of the 2/3. All right, you also have to put a plus or minus in front of this side, because if you think about 4 to the 3/2 power, that's the same thing as me taking the square root of 4 and then me cubing it. And remember, anytime you introduce a square root into a problem, you have to put a plus or minus symbol. So just remember, with these radical problems, you're going to have to put a plus or minus symbol when you get to this step. All right. So moving forward, this is x minus 1 equals plus or minus. Again, 4 to the 3/2 power. This goes back to our first unit. This will be the square root of 4. And then you need to raise that to the 3rd power. So this is x minus 1 equals plus or minus. The square root of 4 is 2. All right, and I have to raise 2 to the 3rd power. So x minus 1 equals plus or minus 2 to the 3rd power is 8. And then you set x minus 1 equal to positive 8, and you set x minus 1 equal to negative 8. Okay, so that goes back to that last unit when we were solving by taking square roots, or start the last section, quadratics, when we had to solve by taking square roots. So now I'm going to add 1 to both sides. I get x equals 9. And then here, add 1 to both sides, and I get x equals negative 7. Because these are radical equations, even though we have it written as a rational exponent, a fraction exponent, you have to go back and check these answers also. So we need to check. So the original problem is x minus 1 to the 2/3 power should equal 4. So the first time I'm going to plug in 9. So 9 minus 1 to the 2/3 power should equal 4. Well, 9 minus 1 is 8. All right, so the 2/3 power equals 4. 8 to the 2/3, that means I'm taking the cube root of 8, and then I'm going to square it. All right, if you look at your perfect square chart, the cube root of 8 is 2, and 2 squared does equal 4. So that means that 9 definitely is an answer. All right, so 9 works. This is me plugging in 9 for x. Then I have to come back and check negative 7. I'll use a different color. So I'm going back to the same equation, and wherever I see x, I'm going to put negative 7. So negative 7 minus 1 to the 2/3 power should equal 4. Well, negative 7 minus 1 is negative 8. All right, so the 2/3 power equals 4. this becomes the cube root of negative 8 squared. The cube root of negative 8 is just going to be negative 2. So, because negative 2 times negative 2 times negative 2 would give you a negative 8. So, anytime you're taking a cube root, if your index is an odd number and you have a negative underneath the radical symbol, your final answer would be negative. So, the cube root of negative 8 is negative 2. And then there's a cube root button in your calculator, so you can use that also. And negative 2 squared, well, when I square a negative 2, it becomes a positive 4. So 4 equals 4. So that means that this solution, negative 7, also works. So in my math lab, your solutions would be 9, negative 7. Doesn't matter which order you put them in, but both solutions work. All right, anytime, I recommend to pause the video and try the examples on your own. So this will be a good problem to go back and just do all over again and then come back and look at the example. One of the benefits of having a recorded video. All right, and the last type of equations would be absolute value equations. So if you know anything about absolute value is the distance from a number to 0 on a number line. So for example, if I wanted to know the absolute value of negative 5, it's going to be 5. The absolute value of positive 5 is also 5. They both are equal distance from 0 on a number line. All right, so just notice that regardless of what was inside that symbol, the final answer was a positive 5. So we're solving absolute value equations. So I'm trying to figure out, well, what inside of this absolute value symbol will give me 7 as my final answer? Well, there's two answers. X could be a 7 or X could be negative 7. And that's your solutions. Those are the two answers for X that would give me a 7, either 7 or negative 7. So when you start solving absolute value equations, start thinking about two solutions. All right. So now when I get down to example 11, what you have inside of this absolute value, this green stuff, whatever that green stuff is, it could be 2 or it could be negative 2. So that's how we set it up. We say this green stuff, which is x minus 3, could be a 2, or this x minus 3 could be a negative 2. So that's how you set up the equation to solve. So I'm going to add 3 to both sides. X equals 5. Add 3 to both sides. X equals 1. All right, this would be a good point to stop the video and maybe try example 12. So I would say this is the one I want you to try. You try this example. And then you'll come back and look at the video. All right, so again, same thing. Whatever's inside the absolute value symbol, green stuff, I'm going to set it equal to 8. And I'm also going to set it equal to negative 8. Okay, so that's how you set these up. You should have two equations. Don't try to solve it right there. Don't get lazy and start solving an equation around the absolute value symbol. You want to write down two separate equations. And then you solve both. Subtract 5 from both sides. I get 3x equals 3. Divide both sides by 3. You get x equals 1. Over here, I'm going to subtract 5 from both sides. So I get 3x equals negative 13. And then you divide both sides by 3. So x equals negative 13 over 3. All right, you can't freak out when you see a fraction. It's okay. Fractions are acceptable answers. All right, and I will go and check it. I mean, you don't have to for these, but you definitely want to check it for the radical problems. But these are your two solutions. When you get to a problem like this, all right, automatically, this green stuff. So I ask myself, this green stuff, what could this green stuff be inside the absolute value symbol that's going to give me a negative 3 at the end? All right, there's nothing I can put inside of here that's going to give me a negative 3. All right, the absolute value can't be negative. So whenever you see a problem like this, this is a no solution. You need to stop, and don't do anything else. All right, that's your answer. And that's what they have in this box here, observation. So the absolute value, all right, out here can't be negative. So, and that's the reason why, is because whatever's in green can't be, it's not going to come out negative. So for example, if I have the absolute value of 3, well, that's 3. The absolute value of negative 3 is also 3. All right, neither one of these are going to give me a negative 3. So that's a no solution. The symbol for no solution is that circle with the line through it. So no work was needed there, but you have to observe and watch out for problems like that. All right, and we're almost wrapping this up. All right, when you see problems like this, you need to isolate the absolute value. So you want to get that absolute value stuff by itself. So in this example, I need to add 3 to both sides. So you don't do any separating until you get the absolute value by itself. So this is the absolute value of x plus 9 equals 4. So I'm going to set apart my two equations. X plus 9 equals 4 and x plus 9 equals negative 4. And I'm going to solve both equations. Subtract 9 from both sides. So x equals negative 5. All right, it's okay if x is negative. All right. Subtract 9 from both sides. I get x equals negative 13. All right, and let me just show you. Let's just check this so you can see that it works out. All right, because sometimes students get confused about the final answer being negative. That's fine. So if I wanted to check this, I'm going to go to the absolute value of x plus 9 minus 3 equals 1. Go to the original problem. And in place of x the first time, I'm going to put negative 5. So negative 5 plus 9 minus 3 should give me 1. Well, negative 5 plus 9 is 4. The absolute value of 4 is 4. 4 minus 3 is 1. So it checks. So negative 5 is definitely an answer. Then I'm going to plug in, use a different color. I'm going to plug in negative 13. So this is the absolute value of negative 13 plus 9 minus 3 equals 1. Well, negative 13 plus 9 is negative 4. And I'm taking the absolute value of that. So this becomes 4 minus 3 because the absolute value of negative 4 is 4. And 4 minus 3 is 1. So 1 equals 1. So again, they both work. All right. This would be a nice example to stop and pause the video. All right, the last example, we're going to solve this. Again, you want to isolate this absolute value. So I'm going to subtract 1 from both sides. So this is negative 2 times the absolute value of 3x plus 2, which equals negative 1. Divide both sides by negative 2. All right, because you want to isolate this. You want to do it. You don't want to separate this into two equations until you get that green stuff by itself. So this is the absolute value of 3x plus 2 equals negative, and negative makes a positive 1/2. All right, so now I can split this apart. I would say 3x plus 2 equals 1/2, and 3x plus 2 equals negative 1/2. And then you solve from here. Right, so I will have to subtract 2 from both sides. So 3x equals, you can use your calculator if you can't solve this by hand. When I subtract fractions, add or subtract fractions, I use something called crisscross applesauce. So basically, this minus 2 I'm going to put over 1. And so I cross multiply. I do 1 times 1, which is 1. There's a minus sign. 2 times 2 is 4, over 2 times 1 is 2. So I say crisscross applesauce. So that gives me 3x equals 1 minus 4 is negative 3 over 2. I need to divide both sides by 3. But because you're dealing with a fraction over here, dividing by 3 is the same thing as multiplying by the reciprocal, which is 1 over 3. So x equals negative 3 times 1 is negative 3, and 2 times 3 is 6, and you want to reduce that to negative 1 over 2. All right, so dealing with fractions here. Can't be afraid of fractions. because they're going to show up all throughout the course. Same thing here, subtract 2 from both sides. 3x equals negative 1/2. Let me do my crisscross applesauce. Hopefully I can move it. Won't let me move it. Oh crap. Alright. Just right over, it's -2 and it was 2 here. So crisscross applesauce. Alright, I have to subtract. I'm subtracting 2 from both sides. Let me back up. So I'm at the step now where I'm minusing 2 from both sides. So I'm bringing down my 3x. And now I have to subtract 2 from this. So I put the 2 over 1. So crisscross, so -1 times 1 is -1. There's a minus. 2 times 2 is 4. All over, multiply your denominators, you get 2. So this is 3x equals -5 over 2. And then I need to divide both sides by 3. Divided by 3 is the same thing as multiplying by 1 over 3. So x equals -5 over 6. All right, you multiply the tops and the bottom. All right, there you go. That's it for equations. The next time we'll be jumping into inequalities, and that will be the end of this unit. All right.